So what happens when water changes phases? Let's think about a pan of water. And we're going to start with ice. I'm going to start with a block of ice. And it's a 1 kilogram block of ice. And I'm going to heat that up. I'm going to put some flame under it, and I'm going to warm that up. All right. So let's put aside the increase in the internal energy. What we're going to do is we're going to look at the energy that we're putting in this to change phase. So what's going to happen when I heat this up, of course, it's going to turn into liquid water. And I'm going to end up with a pan full of liquid water. Right? What mass of water am I going to have after I melt it? Well, I'm going to have 1 kilogram. Mass can neither be created nor destroyed. So all we've done is change the phase. We haven't gotten rid of anything. We've gone from a kilogram of ice to a kilogram of water. And now I'm going to heat it again. So I'm going to put some flame under it. And what will happen to it? Well, eventually all that's going to turn into vapor. How much vapor do I have? What mass of vapor do I have? Well, I have 1 kilogram. Even when it's vapor, it's still a kilogram of water. It's just taking up much more volume because now it's dispersed as vapor. So we already said the amount of energy that it takes to go from liquid to vapor is 2.5 times 10 to the 6th joules per kilogram. That's the latent heat of vaporization. How much energy does it take to go from ice to liquid? Well, it turns out that that's not quite as much energy. It takes 0.33 times 10 to the 6 joules per kilogram to make that conversion. And we can call that the heat of melting, or we can call it the heat of fusion. So fusion is where you create ice. Melting, of course, is when you go from ice to liquid. But we usually call this the latent heat of vaporization, and we call this one the latent heat of fusion. So what happens when a vapor condenses to a liquid? Well, it releases exactly the same amount of energy. It releases 2.5 times 10 to the 6 joules per kilogram. What happens when we freeze water? It actually releases 0.33 joules per kilogram. So this phase change is all about exchanging energy. In between, when I heat this up, there's also internal energy changes. When this water has to go from 0 degrees to 100 degrees, we're also going to increase the internal temperature. So that energy goes to increasing the molecular motion, the sensible heat, and that energy eventually will go to changing the phase from one form of water to another.